Okay, we are now live. So welcome everybody and thank you so much for joining us today. My name is Natalia and I'm working on building the community within Energy Web Foundation. Today is super exciting because we are speaking to you about why the 21st century grid needs a decentralized operating system. And the webinar will be led by our dear colleague, Sam Hartnett, who is Research and Market Development Manager at Energy Web. This webinar will focus on Energy Web's evolving technology stack, so-called EVDOS, and it includes a suite of open source software and standards designed for enterprise-grade applications. And we will also discuss how these tools and frameworks can scale digital solutions for DR integration, electric vehicle management, and much more. So we are really excited about it. And before we jump in, just a few housekeeping rules. Please know that there will be a recording that will be shared afterwards in the member Slack channel. And also it will be available in our members dashboard on our website. Also good to know you are auto muted and please, if you can stay that way until you have a question. And we'll be taking questions at the end, but feel free to include all of the questions you have in the chat as we go. So with that, I will pass it over to you, Sam.
Great, thank you, Natalia, and good afternoon or good morning to folks on the line. Excited to share some of this content with you. What we'll be walking through today, as Natalia mentioned, is an overview of the recently released, let's see, before I get into that, I gotta figure out how to make the slides work. All right, here we go. All right, yeah, what we'll be going over today is a little bit of background on why we decided over the last 6 months or so to really evolve our technology focus beyond blockchain into a broader suite of decentralized technologies before getting into some more detail about what the Energy Web DOS actually is, what the different components are, what they do, and then we'll walk through a few examples of how it actually works in practice and hopefully have time for a bit of a live demo of some of the latest toolkits that we're working on as we speak. After that, I'm hoping to leave about 15 to 20 minutes for an open Q&A. So as Natalia did mention, please feel free to post any questions in the group chat function within Zoom. We'll be recording those and we'll be able to address those in that open time, or feel free to save any questions for the end. So on the why, really want to emphasize that we're now really focused on open source and decentralized technologies as a broader category. And I think everybody here is already pretty familiar with the pace of the energy transition and how every year we're seeing the actual deployment of renewables, adoption of electric vehicles, the costs of distributed energy resources. Those are all exceeding even the most ambitious forecasts that we're seeing from organizations like IEA or Bloomberg NEF. And so what that means is that we're really at this beginning part of the hockey stick curve where all of these trends around renewable deployment and decentralization are really starting to pick up pace and putting us on a track where we're moving from a conventional grid operations model of centralized planning and operation of predominantly thermal assets to a naturally distributed and variable power system that's also starting to merge with the transportation sector with the rise of electric mobility. And so there's no question anymore about if digitalization is necessary to have all of these assets participate in a way that can manage the operational complexity and also achieve the variety of social or environmental outcomes that governments and regulators and utilities are actually looking for. And so in support of that, there are a variety of different market designs, from distribution level markets, things like transactive energy, but even more basic things like dynamic pricing, time of use, rates, new forms of integrating electric vehicles into electricity markets. And so all of these market designs and program designs are predicated on having things like digital identity and verified attributes and permissions for all of the variety of actual assets, customers, and stakeholders in these markets. And so I'm sure many of you have seen this slide. This is actually something that Jesse put together back in 2016 when we were first starting the idea of Energy Web. We collectively, as a community, had identified blockchain as a technology that might be an important tool to support this transition and actually enable many of these use cases and help manage some of the complexity in this new system. And over the last 3 years, through all of the workshops we've done, through many of the one-on-one projects, through some of the lessons learned from the work that you all are doing, we've really narrowed our focus, at least as Energy Web, to 2 application domains that we think can apply to many of these different market designs or programs. And they are the areas where we see decentralized technology as a broad category creating the most value. And so why are we now talking about decentralized technology? Well, for the first 3 years, our focus as Energy Web was primarily on bringing the Energy Web chain to life and then developing some toolkits for different applications. And our original hypothesis was, if we develop this infrastructure and share it with the community, that applications will flourish and take off on their own. What we've actually found is that to really go from a proof of concept or a pilot to something that's going to work at scale in a enterprise market environment, there are a lot of valid concerns and potential limitations of focusing on blockchain exclusively. And so when we really think about what would it look like, let's say, to have millions of DERs participating in a wholesale market with very high throughput of communications in terms of activation signals or bidding, when we look at things like storing massive amounts of meter data or customer data on the chain, or having full integration with all of the variety of IT and operational systems that grid operators and market participants are using, there definitely were some fundamental limitations with what blockchain does, but that's not necessarily an issue. The solution to these challenges is not necessarily let's build a better blockchain, but rather let's not use blockchain for things that it's not suited for. And so this has brought us to what we're now calling the Energy Web Decentralized Operating System, which very much includes the Energy Web chain, and it still remains a core part of our focus. But now we're looking at a broader suite of technologies for things like messaging and data storage and identity management and IT integration that will complement the Energy Web chain itself, and then have different other components that are better suited for some of the things that they're designed to do. And just another point on this that I want to bring up is we really are excited about this as having both this combination of open source, which can be really powerful for transparency and building platforms and tools that many different stakeholders can use and trust, but also combining that with decentralized approaches to reduce single points of failure, to enable more collaboration and interoperability. And so we'll talk a little bit more about that, but it's something that I think is worth repeating as things like interoperability between platforms and manufacturers becomes more important, as well as things like security with IoT and all of these different devices that will be coming online in the coming years. So bringing us to what this actually is. And before we get into the details of the components, there are a few concepts that I think are important for everybody to be familiar with. And the first is the concept of decentralized digital identity, or a decentralized identifier. So the concept of a decentralized identifier is maybe best thought of as a passport. So a passport is a global standard for establishing identity and permissions. It contains intrinsic data about an individual, as well as travel history and things like visas that can evolve over time. So a DID, which is the shorthand for decentralized identifiers, is very similar in that respect, in that it will contain both that intrinsic and also variable data that can be as a result of actions over time. But instead of being created by some central authority and administered by that authority, a DID is owned by its creator forever. It lives on a decentralized network, meaning no other party can manipulate it or take it away. And it's something that can be persistent and universal through time and accessed by a variety of different stakeholders and applications. The way you can think of it also as analogous to a URL, which is a universal address for looking up, let's say, the website of a particular company. And in the beginning, a DID is basically just an address with a blank page. But over time, through a process called verifiable claims, different information will be populated to that address, and any other entity that wants to look up that information can either see the claim that is on the identity, or if it's permissioned, some of the underlying data that supports that claim. So just for a simple example, you can envision a residential customer who buys a battery storage system, and when they are having it installed and physically commissioned at their home, they could create a digital identity for that battery. They would then make a claim to, let's say, the installer or the technician who is on site that they are the owner of the battery, that the battery is physically located at a particular address or associated with a particular meter ID, that it is a particular model number that has various attributes around capacity or the ramp rate. And so those claims would be then verified by that installer, who themselves would be authorized, let's say, by the local utility or the grid operator to sign those claims in order to validate that information. There are a variety of different ways that those can be done, either on-chain, off-chain, many different ways to organize the permissions around how different entities can relate to each other. But at a high level, that's how decentralized identifiers work. And so decentralized identifiers will be created for any physical asset or customer or organization that participates in a given electricity market. And those identities and their claims live on the Energy Web chain in something called an identity directory, which is effectively just a master list of all of the identities and their claims. Then different market stakeholders, whether it's a TSO, a local utility, an application developer, will develop things called application registries that function as an authorization layer for those digital identities. And what authorization means is saying, based on the attributes or the verifiable claims of these DIDs, what are they allowed to do? Can they access, let's say in the case of the battery, is that battery qualified to access the market that manages a frequency regulation program? is that electric vehicle eligible to participate in a special tariff, in a special market? Does that customer gain access to a particular IT system or market portal? Some of the other types of permissionings can be, like the example before, which installers or which types of DIDs are authorized to sign specific claims of other DIDs. So authorization's a bit of a broad category, but the key concept is that instead of having one asset have many different digital identities and many different sets of siloed permissions in various IT systems and registries, here you have one universal identity for each asset or organization or person, and that identity can be integrated into multiple different registries depending on its qualifications. And depending on that, then may access one or more other systems that are actually used to operate the market. Those could be decentralized applications running on the chain. Those could be other systems that are already used by market stakeholders today. There's really many, many different ways to actually configure these. So zooming in a little bit on the actual components of Energy Web DOS, there are effectively three different areas that we'll focus on today. The Energy Web Core, which is the Energy Web Chain and a few of those foundational services that you see at the bottom there. Then the software development toolkits that includes Origin and FlexHub, which are things that many of you will recognize. And then the auxiliary services, which are more focused on integration with some of the other IT systems or other blockchain platforms that may be relevant to support the decentralized applications that you all are building. So zooming in a little bit from the bottom up, starting with the Energy Web Chain, I think many of you are familiar by now with what the chain actually is. I believe we have at least a number of the validators on this call. But to put it in the context of what we're talking about here, in most of the applications and use cases that we're focused on, the Energy Web Chain is primarily used for providing proofs about off-chain data, hosting those decentralized identifiers and their claims, and supporting various decentralized offerings that could be things like settlement functions on-chain, or potentially things like stablecoins or any other decentralized application that you can run on a blockchain. I think a really important point to note is that what we've learned, and I think there is growing awareness of, is that blockchain technology, especially public blockchains like the Energy Web Chain, are really not optimized to be messaging platforms or data storage solutions. And so when there's been concern about things like scalability or privacy or cost, those are valid, but again, blockchain shouldn't be used for those different applications. So in the example of communication and throughput, we are building a decentralized messaging network in which nodes will provide high volume, low latency communication services for things like machine to machine interactions that will be built on top of existing communication protocols and standards. And that's a really important piece in this, because many of these use cases do require millions or tens of millions of messages between different actors or nodes in a system in any given market. But the vast majority of those messages don't necessarily require multi-party consensus on an individual transaction level. And so it's possible to design it now that you can have that high throughput messaging services without having to face some of those limitations about achieving multi-party consensus on chain. Same thing with storage. Storing massive amounts of data on chain can be both expensive and also probably raises difficult questions around things like regulatory questions, et cetera. The solution, again, is to just not store all of that data on chain. It could be in traditional existing storage solutions that are centralized, that's fine. But we're also working to experiment with different emerging decentralized storage solutions, including IPFS, that will offer the option to use decentralized storage for those different applications. Both the messaging and the storage, I want to point out, are things that are still, I'd say, in the early stages of development. Those we would expect to see coming more to maturity in the later half of this year. But the three components of the Energy Web chain, the chain abstraction, and the identity directory are all at a relatively mature state that can be used basically now. So in the chain abstraction, that's just a series of APIs that will provide a communication interface between any of the contracts or DIDs or any of the components that an application uses on chain with all of the off-chain systems. The identity directory, as I alluded to before, is a smart contract that contains that universal list of DIDs and their claims. It is not a application registry. We'll get to that later, and it's not controlled by any given actor. Even though it is this list, each identity owner is in full control of their own DID and how their data is managed and shared. So moving up to the toolkits, this is where we start to look more at the application or platform design space. So as I mentioned, the application registries are used by grid operators, utilities, or application developers to determine the permissions and the authorizations for DIDs that want to participate in a given market, product, or service. What we have developed is a reference architecture that can provide a standardized way for any actor to create their own registries, but there are likely other ways that this could be architected, and it's not by any means a full requirement, but it is something that we've used in the implementations to date and something that we believe can make it a lot easier for any of our members or other developers to develop these authorization layers. Again, there are multiple ways that registries can be designed. So they could have a one-to-one relationship between a registry and an application, or in the example of having a consortium of a transmission system operator, a distribution utility, and let's say a regulator could collectively build a registry that would be foundational to a variety of different applications within a different market. Moving up to the two toolkits that folks may be very familiar with already. Origin is, I think, our first toolkit that we ever made, but is by now pretty different and significantly more advanced than even this time last year. Many of you may have seen that the release C of Origin was just published recently, and it now features a variety of customizable modules that support traceability use cases in a variety of different settings. So that obviously includes things like renewable energy certificates markets, but could be abstracted and extended to use cases like PPAs, like electric vehicle charge management. There have been applications based on Origin that look at things like using demand flexibility to avoid renewables curtailment. So it can be used in a variety of different settings. FlexHub is our newest toolkit that is really designed around the use case of integrating distribution level DERs into wholesale electricity markets, whether those are at the transmission or regional level or at the local level. This is one that we'll go into a little bit more detail on later in the presentation, but some of the components that exist now include DER registration, offer management, and governance, meaning, again, around that authorization piece, how different DERs, based on their attributes, are eligible to participate in different markets. Briefly touching on the auxiliary services. So Link is another one of the excuse me, toolkits that's been around for a while, recognizing the need to integrate many of these on-chain components with legacy IT system. So Link isn't one thing in and of itself, but as we've continued to build out architectures for integrating with both server-side systems like SCADA or enterprise billing, and now increasingly with different small, very lightweight IoT devices, we'll continue to build out this library of architectures that can be used to connect with any of these systems and either share data or reference those different applications with on-chain components. On the bridges, I think some of you may have seen that there have been a few different flavors of this, but in effect, a bridge is a set of nodes that enables components like smart contracts or accounts on the Energy Web chain to interact with other blockchain platforms to do things like effective token transfers or data exchange. Those are still very much in their early stages. One of the fun experiments we did was building out a bridge between the Volta test network and the Libra test network. But that's an emerging category that will probably continue to develop over the course of this year and beyond. Closely related to bridges are oracles, which again are just a series of nodes that provide data inputs for contracts on the Energy Web chain. We've built some early demonstrations on top of the Chainlink protocol to support this. And that's really for use cases where it's beneficial to have multiple nodes rather than one data input for a given contract. The other auxiliary services, that's a bit of a blank space, but want to at least acknowledge that although we're really excited about what we're developing now and what we already have developed to date, we recognize that there will probably be emerging needs for other services or functions for things like custody services or potentially key management services. So just recognizing that when we look at this slide, 6 months or 1 year from now, it may be quite different, and also invite you all as you continue to develop your applications to identify some of these other areas where there's a need for more development that would benefit the entire community. And so all of these components can be combined in different ways to achieve a different outcome that you're looking for. None of what I've just described, including Origin and FlexHub, none of those are products in and of themselves. To actually develop an application, just like any full stack application, you'll likely need many of these different components to do different things. And this is not designed to be a replacement for existing IT systems, but rather something that can complement and augment those capabilities, particularly by establishing identity and permissions in a really scalable way for many different assets and stakeholders that want to participate in the market. So now we'll touch briefly just on how this actually works in practice. And so for an origin use case, again, there are different ways to architect it, but in most cases, you would first create those DIDs for all of the different assets, but also the different buyers or brokers or other stakeholders in a market. Those identities then become added to different registries that might be at a local or regional level to participate in whatever platform is being used. Then those assets, as they generate electricity, they are issuing certificates that live on chain, even though the actual data and the framework for establishing those certificates would be established off chain. There's the opportunity for different regulators to approve the framework for that. And then those certificates can be sold and claimed in a variety of different ways. That can happen on chain or off chain. One example is some of the work we've been doing with IREC currently. In that case, the actual claiming of the certificate is not done on chain, but rather in an IREC system. So again, this is not about saying, let's take a market and put the whole thing on blockchain, but rather let's think about where blockchain can be valuable for establishing that multi-party consensus or establishing the provenance of a given digital asset and tracking its life cycle. For FlexHub use cases, very similar story, but here there is some added complexities depending on the market design around some of the communication and data management. So very similar in that a prerequisite to any of these use cases is all of the customers and their assets having digital identities that are curated in these application registries. But then the core application will likely have a lot of off-chain components just given the nature of some of these markets. So for example, the need to be able to translate a customer's preference for price or comfort into an actual operational schedule or ongoing offers into a market may not happen on chain. Similarly, the actual optimization of thousands or millions of different offers, the management of those offers, and then the activation, which may happen at very high frequency and low latency, will again likely happen off chain. The actual data that's used to determine performance could live in conventional AMI systems. It may live in a system that's operated by the DER manufacturer. There's a variety of different ways that'll happen. But then coming back to where there's a lot of friction in markets today about performing financial settlement, those digital identities really form the anchor for linking all those other steps to one customer or to one asset and tracking that customer or asset's relationships with parties like aggregators or utilities or other service providers. So you can come back and reference those identities to really streamline the financial settlement process. And so just to give a brief example of what this could look like in practice, I'd like to just share some of the work we've been doing on the FlexHub toolkit. So everything you'll see now is just a mock-up of what a front-end application would look like for a user, but I want to talk through how the user experience actually works and what's happening on the back end to tie it back to what we've been talking about. So going back through a user journey, if you start with a customer, again, you can envision them going out and purchasing some type of DER. In this case, we'll use a battery as an example. that battery would likely have known characteristics that a grid operator or utility could use to determine whether or not it is eligible or technically capable of providing different types of grid services. And so the customer would download this app. It could be branded in any different way from the utility or an aggregator or whoever would have that relationship with the customer. And the customer would register like they do for any other service. And when the registration occurs, they would effectively be creating that DID for themselves. When they would first log in, they would presumably have no assets underneath their ownership at that time. But what they could do is then register that new battery that they bought in a variety of different ways. There's a manual option, but we're also developing functionality so that if grid operators or utilities start to work with the asset manufacturers to just put QR codes that have standard data fields on the asset as they are purchased, that could automate some of that process. But assuming that it's a manual process, it's effectively entering in these details and confirm. And so what that would actually be doing is similarly creating a DID for that new asset, but also establishing a few claims like that customer is the owner of that asset, that asset has certain attributes. And so eventually, once that asset is actually fully registered and confirmed in the market, that same application could be used to do things like manage the offers or the preferences for that asset and how it participates in the market. It could show performance history, earnings from that asset over time, and that is largely how the customer would interact with the market. So going back to the day that the battery is installed, you could also envision that installer on a mobile app being in the house, and as they go through and do the physical commissioning, validating the claims of that asset owner. But to begin with, they would similarly create their own digital identity through a registration process defined by the local authority. They may have to do some other documentation or training or certification to perform this registration, but in effect, they would be creating their own DID that then had different permissions to, in this case, authorize the claims of another party. So while they would be in the home doing the physical commissioning of the battery, they would similarly be registering that battery and then also maybe entering some additional information that's more relevant to the grid operator and maybe not as known to the customer. And so here they would be authorizing the claims of the asset owner, but also creating their own claims about some of these other physical attributes of the asset itself. So then moving up to the grid operator view, there is in this architecture a fairly simple way then to actually aggregate the different attributes and views of all of the different batteries in such a way that the grid operator gets a holistic view of all of those claims and attributes of the assets in its territory. And it can drill in and authorize different asset types to participate in the market. It can review all of the different orders or offers that are coming in from the assets that have been provided, or drill into any given asset and view its performance history or any of its other details that would be relevant to that grid operator. And again, that is now just surfacing some of that claim information that was provided in those earlier stages and through ongoing operations in a way that is visible in aggregate to that local authority. So that takes me to the end of the prepared content, and I am pleased that we have about 20 minutes left for Q&A. So happy to open it up for questions. And Natalia, I don't know if we want to unmute people or we can just look through the chat.
Yeah, well, thank you, Sam, a lot for the detailed and comprehensive overview of EVDOS. And we already have received a couple of questions, so maybe we can start with them and then we can continue with the ones that are coming in. So Glenn from PGM asked how application registries created and how does ownership work? And do the registers sit in the cloud or on the asset side?
Yes, so the registries are kind of in reverse order. The registries do not sit at the asset level. The registries can be designed in a variety of ways. So you could create it as a smart contract, you could create it as an off-chain application that references the on-chain components. It's kind of hard to be too prescriptive there. How are they owned? That's another it depends answer. So in most cases, it might make sense for a single entity to unilaterally create the registry based on their status in the market. In other cases, it is possible to have almost a two-layered governance mechanism where you might have a regulator, a wholesale market operator, one or more distribution utilities who are all in a given market, collectively setting the rules for a single application registry. So it maybe is a bit of an unsatisfying answer, but it's designed in such a way that it really can be flexible depending on the needs of a given market.
Well, that's a good answer. Thanks for your help.
Great.
And we had another question from Glenn. Are connections like bridges stateless? And with the messaging platform include event-driven stateless functionality, pub or sub design?
So the current bridges are, I would say, fairly limited in functionality to transfer of tokens, and specifically ERC20 tokens between, let's say, the Energy Web chain and the Ethereum mainnet. So if you wanted to, let's say if you had DAI, which is a stable coin on the Ethereum mainnet, and you wanted to migrate some of that DAI to an Energy Web DAI, you would use a bridge. And there are a couple different ways that bridges can work. A common way would be to either lock those DAI on the sending network and mint them on the other. There are other bridges that would destroy or burn those tokens on one bridge and create them on the other. The bridge nodes are effectively smart contracts that can reference both chains. So they almost maintain their own state, but they are separate from the validators or the miners on each network independently. Looking a little bit further ahead, one of the big goals, I'd say, of bridges or interchain interoperability is to expand the functionality to arbitrary data exchange so that you could send any kind of message or whatever between different chains. So there, you may have heard of technologies like Cosmos or Polkadot, which are much, much more sophisticated than existing bridges and do have state because there's effectively things called relay chains, which are like blockchains for blockchains. And it's a whole other rabbit hole to go down to, but maybe a longer answer than you were looking for, but hopefully that helps answer some of them. I'm looking now. And then will the messaging platform include event-driven stateless functionality? Short answer, yes. So right now, in some of the applications that we're designing, we're effectively just using kind of conventional messaging platforms. The idea is to take established standards and then offer a decentralized network of nodes that would provide the same functionality. And yeah, I mean, if there are kind of specific requirements, then it would be really great to talk more through them so that we can add them to the roadmap. But that is, like I said, something that's really probably going to come more like Q3, Q4 this year.
Okay. Yeah, my thinking there was that it would be kind of an on-bus architecture where I wouldn't have to subscribe to any particular asset, but I could be listening for all messages from particular asset type or a particular asset class or members of my asset domain.
Yeah, and I'll be honest, I mean, having one of our architects or folks from the tech team on the line would be able to provide a much more detailed answer, but my understanding is that that's the exact type of functionality that we're working on.
Okay, great. Good to know. Thank you.
Thanks. And we have another question from Bart. I don't know, have you seen it? So what is the vision on private public key management for DID wallets and transaction payments? And are we considering a custodian proxy solution?
So one of the goals of what I just demoed there is to make the user experience as seamless as possible for users. So what you probably noticed is that there wasn't a whole step of creating a mnemonic phrase and writing it down and all that. The short answer, Bart, is yeah, there probably needs to be some kind of custody or key management service to really drive this at scale. Maybe not. I mean, there isn't, I would say, an official, or we as EWF don't have an official solution for that or recommended approach. Our assumption is that each market or each application is going to be different. And in parallel with what we're working on, if you look to the broader blockchain and especially Ethereum space, there's a lot of work happening in that area as well. And so I would say it's probably too early to tell, but just, when I think logically, if you look at just how most people are familiar with interacting with digital products and services, it looks something like username, password, and the ability to reset. Having something that if you forget it, you lose it forever is probably not really practical for most use cases. And so, again, don't really know exactly what it will look like, but for key management in particular, I think there'll be a lot more work in that area to really drive this stuff to scale. In terms of the transaction payments, there's a variety of different ways that we've been looking at this. So things like gas relays, where you could have one basically master account for a given market or geography, paying the transaction fees on behalf of all of the DIDs in its territory is something we've looked at, or looking at things like a prepayment for some number of tokens for all the transactions that can get you for a particular application. Yeah, the idea is to kind of hide much of the blockchain stuff behind the scenes to most users, to just make it as kind of straightforward as possible.
Okay, thank you.
Hello, Julian here. I've got a question, if allowed.
Yes, please.
First of all, thank you. This is really helpful. It definitely furthered my understanding, but perhaps more from a practical standpoint. I would expect, of course, the full value of this energy web token to be unleashed if used by many people. And that, therefore, just a very practical question. Have you got a good feeling of who are the early adopters, which business models are actually using it at the moment, and where do you expect in the near future the biggest demand to come from?
Yeah, so we've kind of identified 4 ways that we think the energy web token would be used in this architecture. So starting with the most straightforward, obviously there are transaction fees that are incurred to pay for gas for every transaction that happens on chain. That one's quite well known. And when we look at Origin and FlexHub, and then abstracting those to kind of the 3 market domains that we see this being applied most in, it would be kind of renewable and carbon markets as one, wholesale electricity / demand response / DER programs as 2, and then electric vehicle programs and management services as 3. We look at, based on our members and some of the different interests we see across those domains, how do we actually see applications being developed? And then we've looked at, okay, well, in this architecture, what would you need to do? Well, first you would need to be listed in an identity directory. So maybe there's a version of this that looks like to be, listed in the identity directory, you stake or you pay 1 token or something like that once. So that could be, a second layer as part of that identity verification step. And then the mechanics of which I'm a little less familiar with, but for the messaging and storage, we are basically looking at running or working with members to run another set of, in effect, validator nodes that instead of providing the consensus on chain, are providing things like messaging and storage services. And to access those services, you could accept payment in the energy web token. And so that's kind of bucket 3. And then bucket 4 could be other uses for the token, like staking to establish reputation, or putting tokens as collateral for some kind of stable coin like we've seen on Ethereum. Those are other uses that are maybe a little more speculative, but are possible. But when we look at how do we actually see the token being used, those are roughly the 4 categories.
Okay, thank you very much. That helps definitely. Is any of these 4 areas really active as of yet, or are they still quite theoretical?
So the most, in terms of the transactions, I forget the number off the top of my head, but there's something to the tune of between 800,000 and 1 million transactions that have happened on the energy web chain since its launch. So that one's very much happening now. Some of these other pieces are definitely in the earlier stages. I would expect realistically 1 to 3 years for some of those to kind of mature. Just as an anecdote, though, it was kind of interesting. Walter, our CEO, was looking back at some data from the early days of Bitcoin and Ethereum. And I think it was something like in the first year, 98% of blocks in Bitcoin were empty. And in the second year, it was like half of blocks. And so it's, I think, kind of a good illustrative point that many of these things kind of take time to actually gain adoption. And as we discussed in this webinar, what at least our focus as Energy Web is trying to bring these enterprise scale software solutions into the energy sector, which itself is very complex and has a lot of regulatory considerations and business continuity requirements. And so just doing it in this space, I think, is something that just realistically doesn't happen overnight. It needs to actually be really well tested and rolled out in such a way that's secure, user-friendly, can improve the business value, et cetera. But that's why we're here. Agreed.
Okay, very interesting. And would you, so if the 800 till a million transactions, so what is the factor you expect in scaling it up? I mean, do you think it's going to explode soon or take a little longer, so to speak? Or perhaps I shouldn't ask that many questions. I should give the floor to others as well, but would be just.
I mean, I can at least offer one. Speculating is always kind of a wild guess. The one thing I can say is the Volta test network was launched, I think about 6 or 8 weeks prior to the production Energy Web chain. And on Volta, it's something more like, I forget the number. I know there's something like 2 million addresses on Volta and maybe 16 million transactions. And so, I don't know if that's I wouldn't necessarily read too much into it as like a timing forecast, but what it at least says to me is that there is a lot of experimentation going on and people testing things. And, with the types of applications and just the nature of these projects, it could kind of be lumpy as, one platform or another comes online. It's really hard to say.
Okay, thank you very much.
Mm-hmm.
And we are actually out of time. So I would like to thank Sam and everyone for joining and for all your great questions. And yeah, Sam, maybe you can wrap up.
Yeah, so thank you again, everybody, for taking the time and for the questions. Just want to highlight a few other resources that you may all be interested in. So firstly, I'm sure many of you have seen, but we published a paper that goes into the background and the purpose of EW-DOS in much greater detail. That's available on the website for download. As I alluded to earlier, the latest release of Origin introduced quite a lot of new functionality, but also consolidated all of the Origin repositories under a single branch in GitHub. So for those that are interested, that's the link there. I want to highlight that the FlexHub repo is going to be made public and open sourced at probably the end of this quarter. And stay tuned. I believe we'll be doing a full demonstration webinar sometime in Q2. If you're interested in going into more detail on any of these topics, myself, Amy, Jesse, Natalia, we're happy to answer any questions. And if you're interested, connect you with the right people on the technology team. And yeah, we're quite excited about where we're headed. And so stay tuned. There'll be quite a lot more announcements in this front and a lot more technical documentation coming in the coming months. So thank you again, everyone, for attending. And I think that's it.
Perfect. Thanks a lot.
Thank you very much.
Bye.
Bye-bye.